Okay, there we go. So yesterday we went over these vocabulary words in detail. So today I'm not gonna rewrite them down. If you don't have the notes, they're online from yesterday. But array is half of a line. So it has an end point and then it only goes in one direction. And it looks like this. Okay. And then remember, if we name array, it matters which way the arrow points. The end point has to be on the same side with no arrow. So I can call this xy, or I could call it yx, but if I call it yx, it has to point that way. Okay, so that matters. Where it doesn't matter with a line, it does matter with a ray. Opposite rays are two rays that have a common endpoint and go in opposite directions like that and make a straight line. An angle, two rays that have the same endpoint but aren't in opposite directions. These are the sides of the angle. Okay. This is the vertex of the angle. It's the endpoint of the two rays. The interior is right here, and everything over out here is the exterior. We have a line here. We have a line segment here. That actually wasn't meant to be a line segment. Sorry, hold on. That's supposed to come up through here and keep going. So we've got a ray here. We have a ray here. This is a ray, and here's another line. Okay. Here's B. And we're going to name all of the angles that have B as a vertex. And if we look at this picture, here's an angle with B as a vertex. And here's an angle with B as a vertex. So there's two. But each of those two angles can have multiple names. Yeah, it's this angle. It goes this way. Yeah. Not for an angle, no. For the line, yes. So, okay, guys, shh. We're going to start with the yellow angle, okay? So we're going to start with all of the names for the yellow angle first, and then we'll do all the names for the green angle. Okay, the easiest one, see this one in the middle? If it has no degree, so if I have an angle and it has a 30 and a degree, that's telling me that that's a 30-degree angle. But if I have an angle and it just has like a number in it with no degree on it, that's one of the names for the angle. Yeah, so I could call this angle 1. Okay, I can't call it angle B because I've got a yellow and a green that both have B as a vertex. If I was on this angle down here where the H is, I could call this angle H because there's no other angle with H as a vertex. But because B has two angles, I can't just call it angle B because I wouldn't know which one I was talking about. No. But I have three letters, A, B, and D for the yellow. So I can call it angle ABD, or I can call it angle DBA. And those are the only two options because that vertex has to go in the middle. Okay, so those are the three ways we could name the yellow angle. Now the green angle has a few more options because see I have a B, a C, a K, and an L possibility. So I have more than just three letters available. So next we'll name the green angle. And the easiest way to name the green angle is to use this 2 here and call it angle 2. But I have a D, B, C I could call it. I could also call it D, B, K. Yeah. Or I could call it D, B, L. And then all three of these, I can flip the first and third letter. So it could also be called angle CBD, angle KBD, yeah, or angle LBD. The only specification on that is that the B has to be in the center because the vertex is always in the center. Okay, so those are all of the possible names for those two angles. Normally what I recommend is if there's a number in there, use that, angle 1, angle 2. There's no confusion at that point. If you say angle 1, I know I'm talking about this yellow angle. If I say angle 2, I know I'm talking about this green angle. Does that make sense? So if there's a number in there, that's the easiest, least confusing way to name the angle. Otherwise, you need to use the 3 letters, unless, like I said, if there's only one angle on the vertex, you can use the letter of the vertex. So questions about A? No. Well, this one, it said name all of the angles. So we did need to list all of them. But if it just says name an angle, then you just can name one.
So we have this other question on this.
Next, we want to name the sides of angle 3. Well, angle 3, I'm going to erase the highlighting now. I hate that I have to do that, but it makes it easier not to. Okay, angle 3 is right here. And the sides of angle 3 are here and here. Which here? No, because angle 3 is, an angle is only going to be between 2 rays. So I have just these two. So angle 3 has 2 sides. I have CE. And I have CB, which is here, or I could call it CA. That's terrible. These two are the same side. So CE only had one possible name, this side, but this side you could have 2 names. So put like a little or in there. No. Because an angle actually only has 2 sides, you only need 2 names. I just wanted to make sure you knew both of the names so that you wouldn't think that one was not right. So you would have either of these two. Okay, another name for angle GHL. Let me erase the screen again. Okay, angle GHL is GHL. You always go in the order of the letters. So another name for GHL, there's 2 other names. Well, there's actually 3 other names. I could call it angle H because it only has one angle on that vertex, so angle H is acceptable. I can call it angle 7, or I can call it LHG because I can go backwards. No. H has to go in the middle.
Okay, so it could be L, H.
G or GHL, yeah. But H, the vertex has to be in the middle. Because if I changed it to like, say, HGL, I would be talking about some mythical angle that went like that. Does that make sense?
Yeah.
Okay. But that angle doesn't exist, so I can't name it. Okay, a point on the interior, in the interior, sorry, of DBK. So first we find DBK, D, B, and K. Now I'm not looking for a point on the angle, I'm looking for a point in the interior. All of this over here is exterior. This is all interior. There's only one point. Yeah. So it's just E. Does that make sense? Okay. If it asked for a point on angle whatever, then you could pick any point on either of the rays. And if it asked for a point on the exterior, it would have been any of these over here. Yeah. Okay, what is the vertex of angle 5? Angle 5 is right here, which goes like this. So the vertex is C. Write another name for ECL. I have E, C, oops, I did that in pen. Oh well, whatever. Actually, yeah. Okay, so ECL can be called angle 4. I can't call it angle C because there's 3 different angles that have C as a vertex. Do you see that? 4, 3, and 5. So I can't call it angle C. I can call it LCE because I can switch those letters around. But I also have this K here. So I could call it angle KCE. And I can also call it angle ECK, which would be angle F. Make sense? Okay. The point in the middle. Yeah. Well, the vertex is when you have the 2 angles where the V comes together. It's like the base of that V of the angle. Does that make sense? Okay. For name the sides of angle 5. Angle 5 again goes here to here. So I have a couple different names. Oops. Okay, so on one side I can have CG, or I could call it CJ. C, not G. CJ. Okay, so this is the same side. And then the other side is either CB or CA. That's an or. So either of these two and then either of these two. Here? No. So when you name an array, you do vertex and then another letter and the arrow goes that way, or you can do BC but then the arrow has to go this way. The vertex, oops, what did I just do? Okay, the vertex has to go with the side with no arrow. So this is vertex and this is the no arrow side. So that's really important with this because the difference, here I'm going to show you, the difference between CB and BC like that, this is an array that does this. This would be an array that did that. This, the one without the arrow, is telling me the end point of the array. Does that make sense? Okay. And then naming a point in the exterior, sorry, can't say exterior apparently, of CLH. So CLH. If I extend this out, this is interior, this is exterior. So I have 2 points exterior. I could do D or E. K is actually on the angle. So you have, here, let me go do this again too. If I have this angle here, okay, any point on the angle or on the red lines are, this is on. Any points in between, like if you were to extend these lines out forever, so any points in this general area are in, interior, or, and then any points around outside are exterior. Yes, see? We have right, we have acute, and we have obtuse. Okay, a right angle will have either this or it'll say 90 degrees. Okay, this box indicates 90 degrees. If you see an angle that looks like this and it looks like a right angle, unless you actually measure it with a protractor, you can't say it's a right angle unless you have the box or it says it's 90 degrees. Acute are skinny. They're cute. That's how you remember acute. They're cute little tiny skinny angles. And obtuse are big, wide angles. So a right angle is exactly 90 degrees. acute angles are less than 90, and obtuse angles are more than 90. And so technically, an acute angle can be 89.9. It's still less than 90. And an obtuse angle could be 90.1. It's still more than 90. So a right angle has to be exactly 90, and everything else is either acute or obtuse. Okay, and so when we look at this, angle MJP, oh, that's not supposed to be an O, that's supposed to be a P. MJP, here's my 90, but my 90 is going all the way to the L. So this is not 90, this is going to be less than 90. So that's acute. And now we're going to measure it. So angles, okay, have the same angle measure.